We're going to take a look at circle geometry then for today. So the first thing that we need to know about circle geometry are the 4 different rules of circle geometry. So these are the 4 rules that we need to know, and you would have looked at them at junior cert as well. The first one is that the angle in a semicircle is 90 degrees. So if you look there, you can see that the angle at the top of that there, that's your 90-degree angle. For the second one then, on the right hand side, the angle at the circumference is half the angle at the centre. So that if we have 120 here, we divide by 2 to get 60. And then if we had 60 here, we multiply by 2 to get 120. Same with this one. If we go back to the first one, that's 180. So therefore, this must be 90. Same rule applies for that one. Okay, the third one then on the bottom left, the angle in the same segment from a common chord are equal. So that just means as long as they are stemming from the same points, so these 2 points here, then that means that they are going to be the same. Now for this one, be careful about this one because it's very hard to see sometimes. So just make sure that you are looking out for this one. It's one that you can forget very easily. The last one then is the opposite angles in a cyclic quadrilateral always add to give 180. So for instance, these 2 angles here add to give 180, and these 2 angles here add to give 180. So other things to note then are if you have a regular quadrilateral, so let's say it's not a cyclic quadrilateral inside a circle. Cyclic quadrilateral means that all of these points have to be hitting the circle. That's all that means. So you could have a cyclic quadrilateral look slightly different. You could have a circle here, let's say, and you could have say 1, 2, 3 and 4, but because all of the sides are hitting the circle, it's still a cyclic quadrilateral. So just be aware of that. It doesn't matter, it might not look like them sometimes, but it still will be a cyclic quadrilateral. So if you had a regular quadrilateral, then just remember that all of the angles inside a regular quadrilateral are going to add to give you 360 as well. So just take note of that. All angles in a quadrilateral add to give 360. So any quadrilateral add to give 360. It doesn't have to be the cyclic one. The other thing to just be careful of is this bit here. So when you're working with circles, be careful of the lengths in the circles, because if they are the radius, they're going to be the same length. So that's something that's useful a lot of the time. So if you look at this circle on the top right, I know that length and that length are the same because they're both radii. So just little things to be aware of. Right, we're going to take a look at a couple of questions. So the first question that we're going to take a look at is this one here, and I'm going to make them big enough so that I can write onto them. I'll go with red. So if I'm looking at this circle here, I'll go through the 4 different ones that I know are on are the different theorems, and it has to be something to do with that 1 and 4, and it has to be to do with the radius. So if I look at this, I can see that that length here and that length here are the same. I know that that length and that length are the same. They're all the same as each other. Okay, so that's something that might be helpful, so just be aware of that. The next thing I can see is that this angle here and this angle here are going to have to be the same because they are stemming from the same points. So there is 1 and here is 2, stemming from the same points. So first thing I'm going to write down is that I know A is going to equal 40, and your reason being they're both stemming from the same points. So stemming from the same points. Okay, and do write your reason. It just makes it so much easier when someone is correcting it, in case that they are given marks for knowing what the theorem is. Just depends on the question if they are, if they aren't, but just make sure that you're writing something anyway. So I know that this now is 40 degrees. Okay, now there's a few ways that we can work with the part B. The first thing is that from earlier I said that this and this were the same, which means that that's an isosceles triangle. So I can pick out B straight away there, and I can say B is also 40. And I can say that's isosceles triangle. Okay. I could also say that I could find this angle here if I wanted. It'd be the same as this because they're stemming from the same points. Other things that I could write then as well is I could find this angle here and say that that's 100, because this is on a straight line. And I know that if I have 40 here, 100 here, take it from 180, I get that answer as well. Okay, so any of those ways are perfectly fine. The other thing to watch out for in this kind of case here is if they had said that this is parallel to this. Okay, now they didn't say it here, but if they had said that, what I could say is that this angle and this angle then are alternate angles, and there's my transversal and my two parallel lines. So you could have also said that, but they didn't tell us they were parallel here, so I can't write that. Okay, so there's the answer to our first question. Right, let's take a look at our second question then. This question here. So from that one, I can see here, first of all, I have a 75 here, and it's inside this shape. And that is a quadrilateral, just a four-sided shape, but it's not inside a circle, so it's not a cyclic quadrilateral. But we know from earlier that in a quadrilateral, everything adds to give you 360 degrees. Now, they have already told me this is 90, this is 90, and this is 75. So all I have to do is I have to add them all up and take it away from 180, and I get that my angle A is equal to 105 degrees. And all I have to write underneath that is angle in quads equals 360. All right, angles in quads equals 360. Okay. Okay, the next part then is I now know that this angle here, I'll do it in red to make it more obvious, this angle here is 105 degrees. And if I turned my circle around kind of 90 degrees clockwise, I would be able to see that the angle at the centre is equal to double the angle at the circle. So all I have to do with that 105 is I have to just divide it by 2. And that's going to get me the angle B. So B is going to equal 105 divided by 2. And that gives me 52.5 degrees. And why? That's the angle at the circle. Is double at the center. Okay, so let's keep going. We'll try the third question, and we have one more question after this then. So if I look at this question here, again, I can see I have that quadrilateral shape outside of the circle. So I know that all those angles had to add to give me 180, and I have this is right angle, this is right angle, this is 82. So when I go and find all those angles and take them away from 180, I can see A comes out to be 98. So it's 98 degrees. And then angles in quadrilateral equal 360 degrees. And there's my reason. Right, if I take a look then at looking for angle B, I can see here that this is a radius and this is a radius. There's no angles, no two angles stemming from the same points. There's no angle at the centre is double the angle at the circle. Oh, there is. So you could have used that this angle here is the angle at the centre, and this angle here is the angle at the circle. They're stemming from these 2 points here. So you can use that. So all I have to do there is I can take the 98 and I can divide it by 2. So B is going to be 98 divided by 2, and that is equal to 49. Okay, and my reason for that is angle at the center is double angle at the circle. Okay. Other things we could have done there is we were going back to knowing that they're both radii. You can then say that if this is 98, I can find this angle by taking away from 180 and divide it by 2 to get my two angles there. That was just another method to do that. Right, last question then. This question here, question 4. So this one's a little bit tricky. There's an awful lot more going on. So there's plenty of ways that we could go with this, plenty of different routes. I'm going to start by just saying, we'll say looking at this triangle here, I can say that I know that this angle and this angle because they're both radius. I can find both of those and I can say that they're both 34. Okay, all I did there was I took 180. I took 180, I minus 112, and I divided that answer by 2, and that gave me 34 to get each of those angles, those little dots there and there, okay? So if I get rid of all the writing on top of that so far, just to make it a little bit easier to see, I have now found those two angles, and those two angles I'm going to write in green. They are 34, so that angle there is 34, and that angle there is 34. So the next thing that I can spot there is if I'm looking at the angle at the stemming from the same points. So if I go for these 2 points here, this angle and this angle are going to have to be the same. So I'm getting that angle there. I'll get rid of all of those again, and I know now that that angle is 34. So I can pop in my 34 in green. All right. Okay, next thing that we can do then is, if I know that this angle here is 34, and I know that this triangle gives me an isosceles triangle because they've told me that, I can get rid of all of those lines, and I can also say that A is 34. Okay, so I can start writing now. I can say A equals 34 degrees. And that's because it's an isosceles triangle, isosceles triangle. And I can also say that angles stemming from the same point. All right, so there's my angle A gotten. Right, the next thing I need to find then is I need to find my angle at B. The other thing that I can spot here is I can see that this triangle here is isosceles, and the reason why I know that triangle is isosceles is because of the radius. This and this are both radius. So if they're both radius, then I can figure out this angle up here by taking from 112. So if I take 180 from 112, I will get that angle, not the B angle, just be careful, it's this angle kind of in here. That angle there is equal to 68. Make my arrow a bit more obvious as to where it's going. So that angle in there is 68. Okay, so if that angle is 68, and I know that this angle here and this angle here have to be the same because I have that isosceles triangle with the two radius, I know that then I will have the angles of 56. So this angle here is 56. And I'm going to use a different color for this whole angle here then is also 56. Okay, right. Last little bit then that I have to do is I can find, running out of colours, I can find this angle in here by taking away 34 from 56. So if I have 34 and what do we say, 56 take away 34 is going to give me 22. So that angle in there is 22. I know that I have a 68, I have a 22, and I can take them from 180 to find my angle of B. So B is going to equal 180 because that's the angles in this triangle here. And I'm going to say minus 22 and 68. And when I do that, I get 90. So my angle there of 90 degrees. And my reasoning for that is angles in a triangle add to 180 degrees, okay? And there's the triangle that I was talking about there. Okay, so that last one, a little bit trickier. With these questions, what you should be doing is trying to find as many different angles as possible, and that will eventually lead you to find all the other angles anyway. But there's definitely loads of different ways to do that question. That was just